So let's try this problem. So I'm just going to do this live with you, and this is actually a pretty difficult problem. So I'm not going to worry about like not using a calculator for this, but because the hardest part is actually figuring out the limits of integration. So we're going to find the area inside the red circle and outside of the blue circle. So we want to find this area in here. So bear with me as I color it real quick. Right, so we kind of want to find this like moon shape. So we really want to take this full circle of 2 cosine of theta, and we really want to take out this gray area. So we want to take out this overlap. So the easiest way to do this problem is probably actually to figure out the full area of the red circle and then taking out the overlap. So let's go ahead and figure out the overlapping area. So since it's just a circle, right, so this is 2 cosine of theta. It's just going to equal pi r squared, and r, right, the radius is going to be half of the diameter, where diameter is 2, so that's 1 squared, so we're just going to get pi. So now I want to take out the overlap. So to do that, we need to know where these curves intersect. So I'm going to go ahead and set the equations equal to each other. So we have 2 cosine of theta is equal to 4 sine of theta. And if I solve for cosine of theta, I get cosine is 2 sine of theta. So I can't do this without a calculator because I can't figure out that area by myself. So what we're going to do is we're going to go to the calculator. I'm going to go to y equals. I have these graphed in polars, but this is actually going to be easier to find in function mode. I'm going to go to Windows. See, I have these 2 equations already graphed here. I'm just going to finish the parentheses off because it bugs me when they're not closed. I'm going to adjust my window to go from 0 to pi. And I'm going to do that because the period of a circle is actually just pi for sine and cosine, because you're going to get the full circle shape with just pi. Otherwise, you're going to get duplicate answers. So what we're going to do is then we're going to hit second trace. I want to find the intersection point between 0 and pi. So they intersect only at this point. So I'm going to scroll over. And that's going to give me an intersection point at theta equaling 0.464. And I'm going to store that on my calculator as alpha A. So that way I don't have to worry about it. Or you can see I kind of worked a little bit of this out earlier. So this is the point here, and it's r comma theta. So if I go back to my, if I go back to the calculator, which I have up, I didn't have to do anything, I'm going to switch to polar mode, so that way I can evaluate this. Okay, so I want to know, I'm just going to delete everything out. Right, so there's my alpha A. I'll just type it in again to show you. So the radius is at the same point, so that's 1.789. So this is the point 1.789, and then my theta value of 0.464 radians. Now, it looks like they intersect over here as well. Now, the hard thing about polar curves is that sometimes they look like they intersect, and they actually don't, because things are based off of the theta values, not just like how they appear. So it happened to work out that the same theta value for 0.464 radians, we have the same radius value. They don't actually intersect here at 0. They are in 2 different spots, but that's okay because we just need to analyze which curves we need to get there. So for this overlapping region, we actually need to split this into 2 integrals. So if we look here, below the yellow line, right, I'm going from the pole to the blue curve all the way out to when I get to that intersection point at 0.464 radians. Remember, this is our theta value here. And then after that, I switch over to my red curve, right? So that I'm going to need 2 different integrals. So I actually need to know where the blue circle starts for that bottom part, and then I need to know where the red circle ends. So we're going to start this out. So we're starting with blue. So let's see, my overlap, label what we're doing. My blue integral is going to be first. It's going to be 1/2 the integral, and I'm going out to that 0.464 spot. And I know that curve, the blue curve, is 4 sine of theta, and I'm going to square that. I just need to figure out where this starts. So I'm pretty sure it starts at 0. So if we go over here, I'm looking at, I think my colors are backwards. We should flip this. I'm going to change this just so that way the color is the same as it is on, there we go. And then we'll make this one blue. Should be able to just go left. Okay. It's just going to bug me otherwise because it's the backwards color coding. There we go. Now it matches. So if I plug in 0 for theta, I do get that my radius at the blue curve, the sine curve, is 0. But look, it's at 2 at the other spot. So those are two different places, which is why they don't intersect at 0. So over here, this intersects at the point 0, 0. So we're going to start down there for our theta value of 0. And then I'm going to add my red area. So that's going to be 1/2. I'm starting at the intersection point here. And then I want to go all the way out to where, right, so I'm following the curve along here until I get down to this point. So since this is a cosine curve, I want the cosine equation to equal 0, and that's going to happen at pi over 2. So let's just check that. We got pi divided by 2 in here. Right, see, my radius is now 0 for the red curve, but my radius for the blue curve, the sine curve, is at 4. So they're in different locations technically. So this is also the point 0, pi over 2 for the red curve. So I'm going to put this here. And that is going to be, right, we're doing 2 cosine of theta squared in there. Just move that up out of the way. Right. So now all I'm going to do is go to my calculator and type this in. So I'm going to go back here. We're going to go to our home screen. I got 0.5, math 9 for my integral. I want to go from 0 to my intersection point at A of my first, that's my second curve squared, right? I have that in R2. So going back inside my integral here, I'm going to go alpha trace R2, square that, d theta it, plus 0.5 of math 9. I'm going now from my intersection point to pi over 2. I want to use those exact values where we cannot h over 2. That's not good. Pi, there we go. And now that's my first curve. Because I typed the cosine curve in first. We're going to square that. So our area is about, of the overlap is about 0.9617. So the area outside of R equaling 4 sine of theta and inside R equaling to cosine of theta is going to equal the total area of the circle, so pi, minus the area that we just found. So I'm going to go to my calculator and do pi minus the answer I just found, and that's going to give me 2.1799, right, which is about 2.180 radians for my area there.